Hello guys. So today we are going to learn about canonical rates of change. So last lesson we already learned about the change rule, right? So this is the extension part of change rule. Okay, let's move to the first part of it. So here you can find that the water drips from a tap into the container and the volume of water V in the container increases and the height edges also increase. Okay. So here the problem is, can you calculate the rate at which the volume and the height increase are connected or find the exact volume or find the exact rate of that? Okay. So here is example. Like here is a water drips from a tap at a rate of 5 centimeter cube per minute and is collected in a cylinder glass with a base radius of 2 centimeter. And what is the rate of increase of the height of water in the glass, right? So we can say for this problem, you just want us to calculate for the height over the time. That is dH over dt, right? Okay, that is what we want to calculate. And in fact, we have the rate of the volume change that is dV over dt, right? The volume over time. Okay, so exactly we have the volume over time taken. Okay, so you want to connect it with the two equation because we have to times dV here is dH, right? So we can find that they can be deleted and only we have dH over dt, right? So dH over dt is left. So for this equation, we can set that it can also be transferred into dV over dt, volume over the time, right? And then times 1 over dV over dx. Just consider like the fractional number, right? Okay. So for here, the volume ratio change, we can set is 5 centimeter cube per minute. So we can set here is for 5 centimeter cube per minute. And 1 over dV over dH, the volume over the height, we can set here, the volume means the cylinder volume, right? So cylinder's volume, we can set that using the formula is volume equals to pi r squared. This means the base, right? Then times the height means the height of the container, okay? Pi r squared over times h. So we have the calculate for dV over dH. That is for pi r squared, right? So it's pi r squared. And for this problem, we can set that is 5 centimeter cube per minute. And then times for 1 over dV over dH. So dV over dH is pi r squared, right? So you can written down as pi r squared right here. Okay. So the final answer is for 5 over pi r squared. So here, radius is 2 centimeter, right? So it's for 4 pi centimeter, okay? That is for how we can calculate for this problem, okay? So you can take notes on this slide. I hope you can understanding for how to calculate the ratio here, okay? So also here's the solution, so you can just see through this page and you can just pause the video and just trying to see through the solutions. Okay, so just like what we have already calculated. Okay, so last example like here is that a block of ice is melting at a rate of 3 millimeter cube per minute, and assuming it remains in the shape of a cube, and find the rate at which the x is decreasing when x equals to 10 millimeter. Okay. So for this problem, we can set when what we want to calculate for x is decreasing when x equals to 10 millimeter, right? So we can set for here, we want to calculate for dx over dt, right? But exactly we don't know about dx over dt, so we have to only transfer it to other forms. Like here is that the ice is melting at a rate of 3 millimeter cube per minute, right? So maybe I guess we can calculate for the dV over dt, right? So first we have dV over dt. But we want to make the equation balanced. We have to add it with uh, dv, and here is for the dx, right? Okay. So here also can be transferred into dv over dt times 1 over dv over dx, right? Okay. So here, dv over dt means the ratio of the volume change. So here it means 3 millimeter cube per minute, right? So dv over dt can be considered 3 millimeter cube per minute. And for 1 over dv over dx, we can consider here because the volume of the cube is v equals to x cubed, right? So v equals to x cubed, so dv over dx, you can calculate it as 3x squared, right? So this value is for 3x squared. And here is that when x equals to 10 millimeter, right? So we can just put x equals to 10 millimeter into this equation. So we can say dx over dt then can be calculated as 3 millimeter cube per minute, and then times 1 over 3x squared, right? That is for this problem. And then you can calculate it as 1 over x squared millimeter cube per minute for our final answer, okay? So this is for this problem. Okay, and that is it. And let's move into this problem. And here's an exercise for you. So if you want to try to solve the problem, you can just pause the video and try to do this. But if you want to follow with me, you can keep on going, okay? So for this problem, we can say a circular stain on the floor is increasing at 10 centimeters square per second, right? And find the rate of increase of the radius when the radius is 5 centimeter, right? So for this problem, we can say we want to calculating for the radius change, right? So it's dr over dt. So rate here means the radius ratio with time taken, okay? The dr over dt. So this value can be considered as, because here we have the area with radius, right? So we can say that here we have the dA, the area over dt, and then times dr over the area, right? So also it can be transferred into the area over time times 1 over the area over the radius of the circle, right? So the ratio of the area can be considered as dA over dr, it equals to like area is pi r square, right? So pi r square's ratio can be considered as 2 pi r, right? That is the differentiation for pi r square, because the main is, so what the main variables here is r, right? So it's 2 pi r. And pi is a constant number, okay? So we can just put it into it so that we can say that the dA over dt means the ratio of the area change, that is 10 centimeters square per second, right? So it's 10 centimeters square per second. And then times the ratio. Maybe here is 1 over 2 pi radius, right? So here 2 pi radius, the radius is for 5 centimeter, right? So it's 2 pi times 5, okay? That is for this problem. So then we can calculate it as 1 over pi, like here is centimeter over second, okay? That is how we can calculate the ratio change for the radius, okay? That is it. Okay, and another exercise is you can just solve on yourself, and maybe after the classes you can try to solve this, and you can, if you have already solved this, you can just leave your answer to me and I will reply you. Okay, so see you next time. Bye.